Hello students, good morning. I hope you are fine, beta. Today we are starting our next topic, application of the dimensional analysis. Okay, first application we have done already in last class, beta. There is a three application. First one I told you conversion of the unit. Second, that is how we can make the equation using the dimension analysis, and third one then to check the dimension, that is right or wrong, any equation is given. Okay, so here first one beta we are starting there this one already we have done, conversion of the unit. This one we have done in last class. Here we have done that how we can find this one, n1 u1 equal to their n2 u2. By using this one syntax we can find the convert their one system to the another system. Okay, there another one example already we have done, that how we can convert 1 Newton to the dyne. Here Newton is a SI unit of the force and dyne is a CGS unit of the force here. So here how we can convert this to this, done in last class, that is 1 Newton equal to 10 raised to power 5 dyne. Okay, by using dimensional analysis. Okay, now our next question to use this application. Now here 1 joule to the earth. How we can convert 1 joule to the earth? Then here 1 joule, that is SI unit of the energy SI unit, and earth our CGS unit of the energy, that is CGS unit of the energy. So 1 joule of the energy, how we can convert into the CGS? So here energy, first we will write beta dimension formula of the energy. We know that about the energy always will store in form of the work done. Then work done we can write there force into displacement. First your energy, that is your work done, then work done we can write there force into displacement. Then can you write about this one dimension formula? First we are writing about the force, and force is equal to your mass into acceleration, and this our displacement. Okay, so we are writing their dimension formula. M stand for the mass, so mass we can write there m, and acceleration is a stand for the meter per second square. This one here meter per second square, and this one here meter. So we can write their meter, that will be a length square, and this is our dimension formula for our energy. Okay, so here we have to convert their SI unit you can write their MKS unit of the energy. We have to convert into the CGS unit of the energy. Okay, so how we can convert this one? Let we are taking this one system N2 is our number of this one for the earth. U2 is the dimension formula for the energy in our CGS form, and this is your N1, and here will be your U2. Okay, so N1 given in your question, N1 equal to our 1 joule. What? 1 joule. Here given here 1 joule. Okay, U1 is a dimension formula for the energy. As we know that dimension formula of the energy, dimension formula of energy written here M1 L square T minus 2. So how we can write here? N1 is 1. So here we can write there M1 L1 T1. Here power will be of L square. Here will be your minus 2. Clear? Same here for the other side for CGS term. And U2 we can write there M2 L2 square and T2 square minus 2. This is the dimension formula in the CGS form. Okay, so here we have to find out N2. Then we can write there 1 M1 L1 square T minus 2 and divide by your M2 L2 square T2 minus 2. Clear? So here M1 in MKS form we can write it like this one in mass. Mass for the CGS, then we can write there 1000 gram. Here length square will be there. So in from the CGS how we can convert this one? Length in meter, then we want to convert into CGS. So length will become in centimeter. So meter will be convert into centimeter, then it will be 100 centimeter, and here will become beta square. sorry, here time is given, so here time we want to convert into second, then here we will write a second only, so that's why here also will be a square only. Now here 1 gram, here 1 centimeter 1 second. Clear to everyone? Okay, now here we will solve it. This one, here we can write 1000 into here square of the 100, that's why we can write there 4. Okay, now when we will solve this one, then here will become 7, then it will become into gram centimeter second. Clear to everyone? So this one our converted this energy in form of our CGS. So here came 10 raised to power 7, then we can write there 1 joule of the energy, 1 joule of the energy is equal to 10 raised to power 7 of in the CGS unit of our energy. Okay, so this one is the first application of our dimensional analysis. If you want to convert one system to the another system, like this one we can apply for solution of this one. Now our next application of this one, check the correctness of any equation. If we are writing any equation better, then how we can check these are right or wrong? Okay, anywhere we are writing any equation, then dimensionally always should be equal. Okay, for example, one side if we are taking the something in meter, then another side of the equation should be in meter only. Okay, if I am writing here centimeter, if I am using here this side using centimeter, then another side if I am writing here anything, then this also will be equal to your centimeter only. Okay, if I am using here meter per second, then another side of this one side also should be a meter per second only. Means any equation we are writing, then it should be always dimensionally correct. Left hand side dimensionally should be equal to right hand side. So check the dimensional consistency of the equation. Okay, any equation we are writing, then that is dimensionally right or wrong, then we will check by using our dimension analysis. First one, follow the principle of the homogeneity of the dimension. Homogeneity means both side dimensionally should be equal. Okay, arguments of the trigonometry logarithm function should be dimensionless. Any logarithm function we are using in any equation, any trigonometry function we are using, any mathematical number we are using, all are dimensionless. Okay, for example, if I am writing here y equal to your a sine theta. Okay, in this one y is your displacement, if a is our amplitude, then sine theta, this one is a function of our trigonometry, so this one function always will be a dimensionless. Any trigonometry function, logarithm function, always will be dimensionless. Okay, so here next we will solve this one. Our for example, one question is given, check which of the following option is our dimensionally correct with here half mv square. Okay, here given your relation beta half mv square, dimensionally we have to check this one is the equal to the mgh, mgt, mv and ma, which one is our right option. Okay, so check here beta half mv square, that is our kinetic energy. Energy, in last question we have done the dimension formula of energy. Energy dimension formula written already in last question, m1 L square T minus 2. This is the dimension formula of the energy. So here we have to check that dimension formula, any form of the energy, beta kinetic energy, potential energy, any chemical energy, any energy will be there. So mathematically its dimension always will be this only, joule only. Yes. So half mv square, this is your type of the kinetic energy, but dimension formula will be equal to this only, and energy will be equal to your what? Work done. Okay. So here check their mgh. mgh your formula of the potential energy. What? Potential energy. Okay. Potential energy also your form of the work done. So it's also will be your F dot S only. Okay, if we are checking its dimension formula of mgh, then it will be equal to this one dimension formula or not. So how we can check beta? First one, mgh M stands for the mass. For the mass we can write there M1. G is the acceleration due to gravity. So how we can write there L1 T minus 2. H is your height. So for the height we are taking here L1. M1 L square T minus 2. Yes or no? Now find the dimension formula of half M square. I told you beta any mathematical number will be there, then they are the dimensionless. So we will write the dimension of mv square. M stand for the mass and V stand for the meter per second square. Okay, here square is there. So for this one L square T minus 2 square. So check beta see. Dimension of the MGH, this one, dimension of the half mv square, this one, both are equal or not. See your question here, you have to check which one is the right option which is equal to dimension formula of the half mv square. So first one is our right option, MGH only. Our next question, select the pair whose dimensions are same. Here 4 options are given. Here we have to check which one is the right option whose dimension is same. For this one, first we have to know about the formula. Then first one, your pressure. What is pressure? Pressure is our force per unit area. What? Force per unit area. And stress also force applied on any body per unit area, that also will known stress. Okay, next your pressure again your force upon area, and strain will be beta change in length divided by your original length, that is known as the strain. Okay, so check beta here length and here length, then it will be a unitless. What? Unitless, not having unit, so it is dimensionless. Next our pressure and force your force per unit area, that we can't write this one equal dimension. Strain and stress I told you force per unit area. Strain your dimensionless, that is your change in length divided by L. So these are dimensionally incorrect, this also your wrong option. Here this one your pressure, this one your unitless, dimensionless, this also your wrong option. Here this one option will be our right option, force per unit area. Here if you want to write its dimension formula, so how we can write beta? For the force we can write force dimension formula FA. Okay, write its dimension formula M1 L1 T minus 2. This is the dimension formula of the force. For the area will be side square, yes or no? For the square of the side, then mass raised to power will be equal to your 0, length square T is raised to power 0 only. Okay, so here how we can write there, stress equal to your force per unit area. If we are applying, then its dimension formula M1 L1 T minus 2 divided by L M square 0 L square T 0. Clear? Solve this one. Then here we can write there M1 L minus 1 T minus 2. This one is our dimension formula for pressure and the stress. Both are having same dimension, pressure and stress. Both are having dimensionally equal. That's why this one is our right option. Okay, so like this one beta we can check our equation right or wrong. For example, I am writing here equation of motion, that is first equation, u equal to u plus at. Okay, here you want to check that this equation is right or wrong dimensionally. Okay, so how we can write beta this one equation is right or wrong? Then first we will write the dimension formula of each term. Okay, how we can write? As we know this one, v is equal to velocity we know about this one, meter per second. Sorry. So here how we can write? M stands for the mass raised to power 0. L stands for the length is there meter, that's why here we will write 1, divide by second, that's why here we will write there minus 1. Next will be your initial velocity, how we can write dimension formula, it will be remain same only for the velocity beta, M0 L1 T minus 1. Okay, here a is acceleration, t is time. For the acceleration, how we can write there? m0 acceleration. We know about this one, formula of the acceleration, meter per second square. Okay, so here will be your L1 t minus 2. It will be acceleration dimension formula. For the time we can write there m0 L0 T1, this one our dimension formula for the time. Okay, now put all the dimension formula, all term in this equation. Now here we can write, then here m0 L1 T minus 1 equal to, here you can write m0 L1 T minus 1, and this one plus here acceleration, for the acceleration dimension is this one. So write here m0 L1 t minus 2, this one. Here for the time we can write there m0 L0 t1. Okay, now solve this one. How we can solve this equation, beta? If base will same, then power will add. Yes or no? If base same, then we can subtract power, we can add the power. Now in this one, here in multiplication, check here, base same, this one, power we can add, we can write there 0 plus 0, 0 will be there. For the length, here length, so power will be add 1 plus here 0, 0 only. So for the time their power is minus 2, here is 1. So here power will become here minus 1 only. Okay, here will be a minus 1 only. Clear? Now solve this one. Here will become here during the addition m0 L1 and here t minus 1. This one left, and this is equal to here m0 L1 L minus 1. Okay, so here we can write, beta, left hand side is equal to your right hand side dimensionally. What? Dimensionally. Okay, if dimensionally any equation is right, then we can say maybe it will be right. Okay, so here b equal to u plus, if here we will use beta square, then it will be wrong equation dimensionally. For example, here we are writing square, then here will become square, then here will be this one is not equal to this one, so we will call it dimensionally incorrect. Okay, next another example we can take, beta, for this one. Third equation, if you are writing here s equal to ut plus half at square. Okay, you want to check this equation dimensionally. Check equation dimensionally. Correct or not? Okay, here we want to check this one equation right or wrong. So how we can check this one? S stands for the displacement. For the displacement dimension formula, we can write like this one, m0 L1 t0. Here u is our velocity. Initially in last question we find out dimension formula. So how we can write L1 t minus 1. For the time m0 L0 t1. Acceleration we can write their dimension formula of the acceleration m0 L1 t minus 2. This is the acceleration dimension formula. Time already written here. So keep this one relation in this equation. Then check these are dimensionally right or wrong. For the s we can write this dimension formula. For the s we can write there m0 L1 t0. For the s equal to, check here u is given, dimension formula of u will write here m0 L1 t minus 1. Okay, here into your time m0 L0 t1. Okay, plus half at. Half, but I told you there is no need to write half because numeric value all are dimensionless. That's why we will write only a dimension formula. For the a acceleration we can write there m0 L1 t minus 2. This is the dimension formula of the acceleration. Next our time. For the time we can write there m0 L0 t minus 1, and here square is there, that's why here we will write there square. Okay, clear to everyone? Now we will solve this one. If base same, then power we can add and subtract. So here we can write there m, here power is 0, m power is 0, that's why we can add 0 plus 0 will be there 0. Here L raised to power 0, again here L raised to power 0, that's why here we can write 0 only. T here power minus 1, here 1, here power will become here minus 1 and minus 1, 0 will be there. Clear? Now here we will solve this one. M 0, L 1 and t raised to power minus 1, here 1 will be there. So that's why here we can write there minus 1. Okay. Here will become, sorry, 2. Square will be there, na? Here 2. And solve this one. Here m 0. T square, here square will be there. First we will solve beta the square. Here we can write as it is m0 L0 T0 plus m0 base same power will add, then 1 will be there. Here minus 2 is there beta, here plus 2 is there, that's why we will solve it. Then plus minus it will give you 0 only. Okay, so when we will solve, then here left beta m0 L1 then T0. Check it is right or wrong. Left hand side is equal to your right hand side or not. This one our dimension formula, left hand side this equal to our right hand side. So we can write there left hand side is equal to our right hand side. Dimensionally they are correct. Okay, so this our second use of the dimension analysis, then to check the dimension of any equation, they are dimensionally equal or not. Okay. Next our application of the dimension analysis. Third one, derive the relation between the quantities. Derive the relation between the quantities. Your different quantities are given, then we have to derive relation between them. Okay, so then also we are using our dimensional analysis method. So first one we have derived that one system to another system, how we can convert by using dimensional analysis. Second we have done that how we can check their equations, that is dimensionally right or wrong. Left hand side equal to right hand side. If not equal, then we will write it that equation is not correct dimensionally. Our next year third use that derive the relation between these quantity. So here time of the, for example, time of the simple pendulum, this one is an example. So beta we will solve this some question related with it. Then how we can convert one, how we can derive any relation, any equation using the different quantities. Here first one question. Speed of the wave of the string depend upon the tension force, mass per unit length of the string. Then find the relation of the speed using the dimension analysis. So how we can write? See method of this one, how we will solve. First we will write the dimension formula of each quantity. How we can write? Here we have to find out speed. Speed is the, how is a depend this speed on your force, tension force. If better, what is tension force? Tension is the force which is acting in the string. Okay, string, any rope we are taking, then between the molecule of the string their force will be acting, that force we are calling it tension only. Okay, its unit already Newton only. That's why first our speed we will write their dimension formula of the speed. Then we can write there m0 L1 T minus 1, this is a dimension formula of the speed. Okay, which quantities are given in our question. First we will write the dimension formula of each quantity. Now here tension, for the tension force we can write their dimension formula beta. Any type of the force will be there, but dimension formula will be remain same for each type of the forces. So already we have written this one dimension formula of the force m1 L1 T minus 2. Okay, this our dimension formula of the force. Next depend upon the mass per unit length. Not only mass, that is mass per unit length. Okay, so how we can write its dimension formula? Mass per unit length. Mass is there per unit length, that's why we will take inverse of this one, minus 1 we will take, and t raised to power 0. Here these are the dimension formula of each quantities which are given in our question. Okay, now read our next line. establish the relationship for the speed using the dimension analysis. We have to find the relation of the speed with the given quantities with the tension and our mass per unit length. Okay, so first way of this one, first we will write here speed. Let this one speed is a depend upon, is a directly proportional to the our tension. Here we are using this one here F letter for this one, depend upon the F, its power let we are taking A beta. We don't know, we have to find out how is it depend upon the F. Okay, directly, inversely, square of this one, cube of this one, we have to find out. That's why here we are taking A only. Next, it is a depend upon the mass per unit length. Okay, depend or not depend. If depend, then it is how it is depend square, directly, inversely like this one. That's why here we don't know. We are writing there m raised to power b only. Clear? We have to find out with a speed relation with these quantities. So here we have to find A and here B. How is it depend upon this one? Okay, so this one relation. Now how we can solve this one? Write the dimension formula of each quantity in this relation. For the velocity we can write there m0 L1 t minus 1. Okay, is equal to dimension directly proportional, we can write there for a constant k and there f raised to power a. For the force we can write this one m1 L1 t minus 2 raised to power, here a is there, that's why a only we will write. Next our mass per unit length. For the mass per unit length, our this one dimension formula. So here m1 L minus 1 T0, their power is B we are taking. Okay, we assume this one A and B, you can assume there any letter X, Y, Z, anything. We are taking here A, B. So how we can solve it at this one general equation? How we can solve this power? Multiply this power downside. Here we can write this one side as it is. Okay, K. Here we can write there M A L A T minus 2A. This one M B L minus B T 0 there. That's why we will write 0. Okay. Now K as it is, K beta any constant is there, trigonometry function is there, and logarithm is there, mathematical number, then all are unitless. Okay, there is not having any unit, that's why there is no dimensions. Okay, so that's why here base will be same, that is multiple with each other, base same, then power we can add there. Here m base same, so power we can write there a plus b. Next there L, here L, then power we can write there a minus b. Okay, next our time. For the time we can write there minus 2a here plus here 0. Understood till here? Now this one equal to here, another side we are writing m0 L1 t minus 1. Now here how we can find A and B? We can compare both sides. Then both sides we are comparing, base same, then power we can put equal with each other. So here we can write their base same beta, here this side. Okay, on comparing we can write here, on comparing both sides, then we can write there m base same, so we can write there a plus b equal to 0. Okay, now next here compare this one for the length a minus b equal to our 1. Clear? Now next our minus 2a equal to here minus 1. Compare this one for the t base same, then we can compare its power. So here we can write this one. So we can find value of a from this equation, that is here minus cancel out, then here a will become out beta 1 by 2. Okay, now put value of a here, then b we can write there 1 by 2 plus b equal to 0. So b left here minus by 2. Understood everyone? Okay, so A and B value came. Here we are writing beta A came equal to your 1 by 2, B your came your minus 1 by 2. Yes or no? This only came. Now here return this one relation, put value of A and B, then we will get the relation of the speed with our force and the mass per unit length. Okay, so put in this relation. Here we can write there V equal to directly proportional to the force power is A, that's why we can write there 1 by 2, and here mass per unit length, its power is minus 1 by 2. Minus 1 by 2 we can write downside, so we can write there velocity is depends upon the under root here F by mu. Okay, this is the relation for the speed of the wave on the string. Okay, any string we are taking, then we are releasing it, then their wave formation will be there, then speed of the waves are depend upon these term force and length, like this one relation. Clear to everyone? Like this one we can apply their third use of the dimension analysis in our question. Okay, now beta for the more practice we can do next question related with this only. Consider a simple pendulum having a bob attached to the string. Okay, oscillates under the action of the force of the gravity. A pendulum is given. Here question is there. Like here this one pendulum we are taking. Okay, this pendulum is there having bob. Okay, having a attached to a string, oscillate under the action of the gravity. This one is accelerating here and there under the effect of the gravity. Okay, here let, and after this one given, suppose the period of oscillation of simple pendulum depends upon the length. Okay, but depend upon the length. First we are writing this one oscillation time period. This one given beta, this time period is a depend upon the length. Is not, we don't know about this one, how is it depend directly, inversely, square, cube. Okay, we have to find out how is it depend upon the length of the this one. Okay, time period means time taken by this pendulum for one complete oscillation, that is known as a time period. This one our let we are taking their pendulum, as we are taking there and applying the force, then it will be go in this direction, then again come back in the this direction. Then you have to find out time period of the complete oscillation going from here, then again come back there, then again coming on the mean position. During this simple pendulum beta having two position, one our mean position and one is our extreme position. If we are starting this one from here, then again it will come back on this position for taking one complete oscillation, that is our time period. Okay, so this time period in our question we have to find out, that is how is it depend upon the length of this pendulum. Length is this one our length, this length. Okay, this one length. Okay, time period of this pendulum, how is it depend upon this one length, and second is the mass of the bob. Mass of the bob, this one our bob. Okay, its mass we have taken m. If we are taking here bob, then this time period of the pendulum, how is it depend upon this mass of the bob, then this also we don't know, then it will be directly proportional, inversely square, like this one. That's why beta here we are assuming their power ABC, like this one. Third one is the acceleration due to gravity. This one also we don't depend upon the acceleration due to gravity, but beta don't know how is it depend upon the acceleration due to gravity during the oscillation of this bob. That's why here we are assuming their power we are taking C only. Okay, we have to find these relation of time period with length, mass, acceleration due to gravity with help of the dimension analysis. Okay, how we can apply their dimension analysis? So here proportional sign we can convert into a constant k if we are converting into equal. So we can write there L raised to power A, M raised to power B and G raised to power C. Okay, so how we can find beta this one relation? T time period relation we have to find out with our length. Here length we are taking its power A. Okay, this one we are assuming beta let we are taking its power is A. Next our depend upon the mass of the bob, we don't know how is it depend, that's why we are taking their power is B. Okay, next our depend upon the acceleration due to gravity, we have to find out its relation with the acceleration due to gravity of the time period. So here we have to find beta A, B, and C value. Okay, if we can find its A, B, C, then we can write the relation of the time period of the pendulum. Okay, I told you beta what is time period. From here that bob is moving from this side. This one your mean position, we can say equilibrium position also of the pendulum, and this one we will call it extreme position. Okay, that is extreme position. It is moving here, then again coming back on the position, on the extreme position, then again come back here, mean position. So total time taken for the one complete oscillation, that is known as the time period. So here we have to, first we will write the dimension formula of each term. First our time period. For the time period, how we can write there? M1 L0 T1 we can write. For the next our length for this one we can write there M0 L1 T0 we can write. Clear? Next our mass will be there. For the mass we can write there M1, L stands for the length is not there, that's why here we can write 0. T also not here, that's why T also power is 0. That's power is 0, if any term having power 0 then we can write it 1. Okay, we can leave it, otherwise you can write if your choice. Okay, now G is our acceleration due to gravity, acceleration also only, that's why we can write its formula M0 L1 T minus 2, this one our dimension formula for the G. Now put here value of this one T. For the T we can write there M0 L0 T minus 1. Put dimension formula of each term in this one relation. Okay, so here after putting this one, then we can write there L raised to power, L is this one, dimension formula of length M0 L1 T0, its power is A. Next our for the length we can write there M0 L1 T minus 0. Okay, its power is B, we can write there B. Next our G, for the G we can write there M0 L1 T minus 2, here power we can write there C only. Clear to everyone? Now after this one we will solve it same as it is, your power base will be same, then power we can add and subtract because all are multiple with each other. So here we can write there M0 L A T0 we can write. First we are multiplying beta this power inside this one, dimension formula M0 LB T raised to power 0 M0 LC T raised to power minus 2 C. Okay, after this one base same, then we can add the power, here base same M. So here we can write there 0 plus 0 plus 0, its power is 0 only, then 0 L, its power is A, here L power is B, that's why we can write there plus B, here is C, now here we can write there plus C. Then for the time here 0, 0, then here minus 2C. Clear? Here we can write beta this one side, here M0 L0 T minus 1. After the comparison then we can write it for this one mass, here will become na 1 only. This one dimension formula of the mass, that's why we are writing here 1. Here also will be 1 bit. 1. G. B. Okay. Now we are writing this one on comparison. We can write here beta this one. Now on comparing both sides, on comparing both sides, we can write their mass, here also mass, that's why on comparison we can write there B equal to 0. Now this one side length is given A plus B plus C, here we can write equal to 0, A plus B plus C equal to 0. Next our time, for the time we can write its power is minus 2C and minus 2C is equal to minus 1. Okay, minus 2C is equal to here minus 1. Solve this one, minus 2 minus we can cancel out, this one cancel out, so C value will become out beta 1 by 2. Okay, B our 0, C our this one, then can you find this one value of A from this one relation? How we can find A plus B our 0 plus C, C is equal to 1 by 2 equal to 0. Now take this 1 by 2 another side, then A we can write there minus 1 by 2. Okay, so here we can write beta A equal to this one, B equal to our 0 and C our equal to 1 by 2. Came value of ABC. Now put in this one relation of value of ABC. So we can write this one T directly proportional to the L raised to power A. L raised to power A. Okay, A is equal to here minus 1 by 2. Now there M raised to power B, B our 0, that's why here we can write its power 0. Next our G, okay, G is acceleration due to gravity, its power G, C. So here C will be equal to our 1 by 2, we can write there G raised to power 1 by 2. So our relation came this one. Now we can write its power is 0, that's why we can leave it. So we can write there T directly proportional to the under root G by L. This is our time period for the simple oscillation. Okay, so here we can conclude beta that the time period of the simple pendulum is not depend upon the mass of the bob, it is a depend upon the length of the simple pendulum and depend upon the acceleration due to gravity. How is it depend? Directly under root of the G directly depend and inversely of the length of the under root. Okay, and mass that is independent upon the mass of the bob. Like this one beta, we can apply their dimension analysis to derive any quantity using your different way. Okay, dimension analysis. Now next question, using this one we can apply beta. Escape velocity of V depends upon the acceleration due to gravity G of the planet and radius of the planet, then derive the relation for the dimension. This also beta same method we have to apply of the dimension analysis to find their equation. How we can write escape velocity? Escape velocity again beta same method we are applying. In question is given velocity, how is it depend upon the velocity on the G, acceleration due to gravity. Second is a depend upon the radius of the planet. We don't know about this one, how is it depend. That's why here power of G we are taking A and power of R we are taking B. Okay, we have to find out value of A and B, that is depend upon square or inversely, cube or not, depend upon these or not. That's why here we have to find A and B value. If you can find A and B value, then put here, then velocity will be there. Yes or no? So write their dimension formula for the velocity. First we are writing dimension formula of velocity. M0 L1 T minus 1. Okay. For the gravity acceleration due to gravity, M0 L1 T minus 2. For the R we can write. For R, what is R here? R is our radius only. So radius is in term of the length. So M stands for the mass. Mass will be 0 only. Then your length. Then radius is for the length unit. That's why its power we will take 1 and time we will take 0 only. Okay. Put here in this one relation value of the dimension analysis here. Now here after putting, then we can write there M0 L1 T minus directly proportional to the G minus 2 A, and here for the radius we are writing M0 L1 T0, here power we will write here B only. Okay, so after this one, solve this one, here power M0 LA T minus 2A. Here we can write there M0 LB T0. Clear? Base same, then power we can add, again same method we are applying here. Here only we are solving, then here M, here power is 0, here 0, that's why here we can write 0 only. Here length its power is A, here length its power is B, that's why here we can write there A plus B. I told you beta base same will be there, then we can add the power. So here time is there, time minus 2B, and here we can write there plus 0. Okay, now another side of this one. Here we are writing this another side is equal to velocity, that's why write here M0 L1 T minus 1 for the velocity dimension formula. On comparing both sides, so we can write there A plus B equal to here 1 minus 2B equal to here minus 2. We can find value of A and B. From here we can write there B equal to here 1 by 2 and put value of here B 1 by 2 equal to our 1 only. So here we can write there, it will be here minus 1, then we can write there 1 by 2. After solving this one, then our value came A equal to our 1 by 2 and B also came our 1 by 2. Okay, put value of A and B in this our first one equation. Here we can write first equation. After putting this one, then we can write G raised to power 1 by 2 R raised to power 1 by 2. So we can write there under root our G by R. Okay, this one our relation of the escape velocity with our G and R. Okay, escape velocity, that is a velocity which is the maximum velocity required to escape any object from our earth atmosphere, that our escape velocity. Okay, how is that depend upon this one? This is a depend upon our acceleration due to gravity and radius of the planet. Okay, that is known as a application of the dimension analysis. Thank you.